Alright, so today we're going to talk about equations of circles. But before we do that, we're going to kind of compare them to an equation of a line. So remember, we've graphed lines before, and that equation is y equals mx plus b, where b is the y-intercept, the starting value, and that your m is the slope, or also known as your rate of change. Okay. So we have those two characteristics, a y-intercept and a slope of a line. Now, when it comes to a circle, the two characteristics we need to know is the center of the circle, and we need to know the radius of the circle. That will allow us to graph a circle in the coordinate plane. So let's derive the equation of a circle. So we're going to figure out where it comes from using Pythagorean theorem and the distance formula. Because remember, Pythagorean theorem is just a form of the distance formula. So the center of this circle is at 0, 0. Now any one of these points on the circle, okay, we want to come up with an equation that works for any one of these points. So let's look at this one, for example. Well, we know the radius is this distance right here, from the center to a point on the circle. The x distance, or the distance in the x direction, okay, that's one side of the right triangle. And then here is the vertical distance, or also the y value. So we have 2 points here. We have x, comma, y. And I'll use a different color. Okay, so the y value is how tall, and the x value is how far over left or right. So remember the distance formula, x2 minus x1 squared plus y2 minus y1 squared. And we're going to just use 0, 0 as one of our points. We can say that that's x1 and y1. So x1, y1, that's 0, 0. That's where the center of our circle is. And that x2 and y2 is just going to be any point we pick on the graph. So we're going to leave those as variables for now. So the distance is equal to, well, we don't know what x2 is, so we can leave that as x2 minus, well, x1 is 0 squared plus y2 minus 0 squared. Okay. So then that gives us distance is equal to, well, x squared minus 0, or x2 minus 0 is just x2. So this simplifies to just x2 squared plus y2 squared. Because when you subtract 0, nothing changes. Now, if we square both sides of this equation to get rid of the square root symbol, we get that the distance here is equal to x2 squared plus y2 squared. So that will help us graph circles. And then remember Pythagorean theorem. Oh, whoops, I forgot to square this. There we go. So this distance squared here is equal to the distance in the x direction squared plus the distance in the y direction squared. And that is what Pythagorean theorem says. We have a squared plus b squared equals c squared. Our parts of right triangles. Alright, so that was when the center was at the origin, or 0, 0. But what happens if our center is not at the origin? So our center here is at 2, 1. I'll use a different color. And again, any point on the graph we're going to call x, y. And we'll do the same thing if we use that distance formula of x2 minus x1 squared plus y2 minus y1 squared Okay, so then our x1, y1, that is going to be 2, 1, the center of our circle. And then our x2, y2, we're just going to leave those as variables, x and y. And the distance that we're trying to find from here to here, that's r. That's the radius of the circle. So then we can plug these things in. So we get r equals the square root of x minus 2 squared plus y minus 1 squared. So I'm just plugging in the values from over here into the distance formula. Then if we square both sides, we get r squared equals, these cancel, we get x minus 2 squared plus y minus 1 squared. So notice that even though the coordinates of the center were positive 2, positive 1, in here we see x minus 2 and y minus 1. It's the opposite of what you see. Okay. So this was just kind of an overview on where the equation of a circle comes from. You don't really need to reproduce this proof that we did, but you do need to know, given the equation of a circle, what the center is. All right, let's look at the next page. So the standard equation of a circle with the center at 0, 0 is going to be x squared plus y squared equals the radius squared. That's our standard equation of a circle that is not shifted left or right, that the center is at the origin. Now, if the center is not at the origin, then the equation is going to look like this. So again, the center, that's at h, k. So the opposite of what you see. And r is your radius. So let's look at some examples, and I think you will see that this is not too bad. So write the standard equation of a circle with the given information. So the center is at 0, 0. That means my h value is 0, and my k value is 0, and a radius of 6, so r is 6. So I'm going to plug that in to my equation up here. So x minus 0 squared plus y minus 0 squared equals 6 squared. X minus 0 is just x. So we get x squared plus y squared equals 6 squared is 36. And that is it. We don't do anything further. Now b, center is at negative 5, 2. So h is negative 5, k is positive 2, and r is also positive 2. So then we do x minus h. Well, it's going to be -5. So the x minus part comes from the formula, and then the -5 comes from the h value. So that's why we have a minus minus. And then when we have that minus minus, that changes to plus, so it's going to be x plus 5 squared plus y minus 2 squared equals 4. So you don't always have to write out these steps. I'm just going to for the first couple so you can see how the h and k values are used. You know, the center was at -5, so in my equation it was x plus 5. The y value was 2, so it was y minus 2. The first number always goes with x. The second number always goes with y, like an ordered pair. Now, letter C, our h value is 0. Our k value is -3. The r value, though, they're telling us right here the diameter is 10. That means the radius must be half of that, or 5. So then that will give us x minus 0 squared plus y minus -3 squared equals 5 squared. So x squared plus y plus 3 squared equals 25. All right, so we were given that information up here originally, and we wrote the equation. Now what we're going to do is we're going to look at a graph, and from the graph write the equation. So the first thing we need to do is find the center. There's the center of this circle. So your center is at 0, 0. The radius. Now instead of trying to go diagonally and count, let's count vertically or horizontally. Go 1, 2, 3. So your radius is 3. That's going to give us x squared plus y squared equals 3 squared, which is 9. We don't have to write -0 if we're centered at the origin. Like up here, you see we were centered at 0, 0, the origin, and we just had x squared plus y squared in our answer. All right, letter B, your center is at 1, 2, 3, 4, 3. So your center is 4, 3, and your radius is 1, 2. That will give us x minus 4 squared plus y minus 3 squared equals 2 squared, which is 4. And then the last one, our center is right there. So your center is 1, -1. And then your radius, 1, 2, 3, 4, 5. So then the equation is going to be x minus 1 squared plus, this is going to be y minus -1, because we have a -1 right here. So it's going to be plus 1 squared equals 25, because 5 squared is 25. Okay, so whenever we want to write an equation of a circle, we need the center and we need the radius. And there's a lot of ways we can get those. Alright, so let's look at some congruence and similarity properties of circles. Are all circles congruent? Remember, congruent means the same size and shape. No, obviously not all circles are congruent. We have a bunch of circles up here that are obviously not the same size. No. Congruent means same size and shape. Now, when we talk about similar, remember similar just means that it's the same shape, that size can be different, that you enlarge something or shrink something and it becomes similar. So yes, similar because they have the same, circles all have the same shape. They're all round and they all have a radius, but they're not the same size. Okay, and then we're going to do a little bit of work to prove that all circles are similar to each other. Now remember like I was saying, when we proved that polygons were similar, if it was the same shape, we could either reduce it, shrink the shape, or enlarge the shape, and they'd be similar. And mathematically what we did is that we looked at the corresponding parts, and we found that they were proportional. So what we would have to do is we would have to look at the corresponding parts. We need to show corresponding parts are proportional. Well, in a circle, we only have two parts. We have the radius or diameter. They're kind of the same. They're not exactly the same thing, but they can be used similarly. So we have that, the radius slash diameter, and we have the circumference of a circle. So we're going to compare those. So how should the circumference and diameter be? They should have the same scale factor. Alright, so let's look at this part. We're going to calculate the circumference at each of the circles in example 2. Remember, the circumference is 2 pi r. Circumference equals 2 pi r. So in the first example, part A of example 2, the radius of that circle was 3. So the circumference equals 2 pi times 3, which is 6 pi. And the diameter is 2 times the radius, or 6. So I'm going to leave that there for now. Then for part B, the radius was 2. So the circumference would equal 2 pi times 2. The circumference would be 4 pi, and the diameter was 4. And then for part C, the circumference is 2 pi times the radius. The radius for that one was 5. So the circumference is 10 pi, and the diameter was also 10. So look what's going to happen if we write the ratio of the circumference over the diameter. So if we do 6 pi over 6, 6 cancel, we get pi. If we do that for part B, 4 pi over 4, 4's cancel, we get pi. 10 pi over 10, same thing, we get pi. So we have the same scale factor in all three, parts of example 2. So yes, all circles are similar. Yes, they have, they have the same scale factor. So they are proportional. And that scale factor is pi. So if I take the diameter of any circle and multiply it by pi, that gives me the circumference. That is why all circles are similar. Alright, in example 3, it's asking, can you transform circle D to D prime by translating it, then performing a dilation? Write the translation rule and the dilation. So we want to first translate D to D prime. So we want the centers to match up. So for the translation, what we are doing is we're going to take the x value and then we're going to go 1, 2, 3, 4, 5 right. So we're going to go 5 right. So x plus 5, comma, how far up do we go? 1, 2, 3, 4, 5, 6, 7. So y plus 7. So that's our translation rule. Now we have to dilate it to figure out how big to make this. Now the radius of D is 3 units. The radius of D prime is 1, 2, 3, 4, 5 units. So remember, in a dilation, our k value is going to be the image divided by the pre-image. And in this case, that's going to be 5 over 3, because the radius of D prime, our image, is 5, and the radius of D is 3. So then our dilation, that rule is going to be x comma y to 5 over 3 times x and 5 over 3 times y. So those would be the rules that would map D to D prime. Okay, what I want you to do is pause the video, try example 4, the same way we did example 3 up here, and then once you're done, unpause the video so you can check your answer. Okay, in example 4, here's our pre-image right here, P, and here is our image up here, P prime. So for our translation rule, it's going to be x comma y, and it's going to be x, and we are going up our surface. We go left first. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be x minus 8, comma y, and we are going up 1, 2, 3, 4, 5, 6, 7, 8, 9. Y plus 9. So that is our translation rule. Then our dilation rule. Okay. And this the radius of P prime is 2. So k is going to be 2 over the radius of P, 1, 2, 3, 4, 5, 6, which is 1/3. So the rule for that would be x comma y, 1/3 x comma 1/3 y. Okay. So I know that this was a lot, and there's actually a lot of information here that's kind of a little bit extra that if you don't understand completely, it's okay. The main idea that I want you to get from this lesson is this part right here. this part right here. If there's only one thing you're going to get from this video, it's got to be this part. Knowing the equation of a circle, being able to write one from the information, like in example 1, and then being able to write one from a graph. Tomorrow we're going to work on actually drawing and graphing these. Right, so really focusing on this part, and ask me questions if you need help. Bye.